This is the Amp Hour Podcast. Released February 5th, 2023. Episode 618. Refrigerators and Robots with Amitabh Shrivastava. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
Hi, this is Amitabh Shrivastava. I'm a maker from Jersey City.
Hey, Amitabh, how are you?
Pretty good. How are you doing, Chris?
The last time I saw you, you were refrigerating fireball shots on the run. On the go.
Yeah.
It was a very impressive setup you had. And I was like, you and I had talked, I think, at Maker Faire or something prior to that about your last project.
2019.
Yeah. So I'm really glad you're here. I'm really glad we're going to be talking about some of this stuff.
I'm very excited to be here. I mean, I used to listen to the Amp Hour as an undergrad student back when I was studying physics and, was like deciding on becoming an engineer or not. So
tell me about that. So physics, and I mean, I'd say you are squarely, I've seen the stuff you build. I'd say you're squarely in the engineering space. You are applying those physics skills. So what was the switch over? Like, what was the interest in studying physics and what was the switch to engineering?
Yeah, I mean, so I've been interested in like making stuff since childhood, like, the typical thing of taking toys apart and like, trying to make stuff. And
you had the knack.
Yeah, yeah, exactly. But I had a curiosity for astrophysics in particular. Like, in high school, I did an internship on exoplanet detection. And so I was like kind of on track to become an astrophysicist. Like, there's this big engineering exam in India. I don't know if you know about it. It's called the IIT JEE.
Okay, no, I don't know about it.
So it's like the national, like imagine like the MITs.
Okay.
And there are like a bunch of them in India, and like they have like one entrance exam.
Yeah.
And it's the dream of every high school student in India.
I've definitely heard of IIT before. Yeah, I know. Yeah. Yeah.
So, I didn't realize I took the exam and
specific exam just for that university, though. You're saying?
Yeah.
Oh. Okay.
So I took the exam and like I got through and like and then I was like, no, I don't want to do this. I want to do physics.
Oh man, turning down. You got to the gate. You're like,
that's what. Gotta play that card.
Can you imagine the amount of astrophysicists that are going to pop out of the woodwork after like the James Webb Space Telescope? Like just like there's just, I mean, obviously there's a lot of stuff to be done in the space, but like just the images that have come out of that and the interest level, I can only imagine. I would hope that my high school physics teacher was showing those images and inspiring young minds like that. So I have to imagine there's a healthy young crop going to be going into that.
Yeah, I mean, but actually, so I got turned off of physics from like through an astrophysics internship, actually.
Oh, really?
Yeah, I was studying in Bangalore, India, right, at an Institute of Science, and I was doing an internship at Brandeis University in my third year of college on radio astronomy, right? And I was like super focused on astrophysics at this point. But I just realized that most of, astronomy is like coding now. It's like running simulations and, just analyzing data and all of that, because you're not actually like, you have this vision of like, you're in this observatory in Hawaii somewhere with a big telescope and looking at stars and like, kind of like, oh, there's a wobble in that star, that's funky signal or something. It's not that at all.
The computer gets to look, not your eyeballs.
Even for James Webb, right? I mean, sure. It's difficult now to tell like, what, what's with cameras in your cell phone, for example, right? Whether it's not actually taking an image, it's creating an image, right? Artificial intelligence.
It's averaging, so, and it's
same with
it's
James Webb Telescope, probably.
Right. It's a good point.
Yeah,
I think about the one woman that like revealed the black hole image they did a couple months ago at this point, right?
Yeah.
And she was just talking about her Python script was running for like a really long time to like stitch together all these different images from the different satellites, right? To make that black hole image, and it just sounded like lots and lots of code.
Yeah.
Interesting. So, and radio astronomy, I imagine too, is like, I'm sure there's like the the applied aspect of building radio telescopes, but that's probably
Sure. Yeah,
pretty
definitely.
far separated from the physics programs, right?
Oh yeah, certainly. I think,
Mm.
but also with radio astronomy, like there's one neat trick which essentially you have multiple radio antennae all over the world, and it's like
Oh
a
yeah.
VLSI array, very large scale interferometry array
Hmm.
of radio
Hmm.
telescopes. And essentially, using like multiple small antennas, you can create, like, you can essentially emulate an antenna the size of the planet Earth.
Yeah. Yeah.
And so at that point, any single antenna's data is nothing. You have to combine all
Right.
of that data, and that's the only thing that you have. So, like, yeah, the computer is doing all the work.
Well, take that, college professor who taught me matrix math. I didn't need it after all. Well, so then what was the hop over to engineering? So then you started building stuff instead?
So I'd been building stuff through this while, right? Like, for example, in my first second year physics lab, every week, we'd have like 3 days of physics lab. And the first day, the experiment would be introduced, and, like, I'd be like, okay. And then that night and the next day, I would figure out a way to automate that experiment with like an Arduino or
Uh-huh.
some
Yep.
using the audio data in for my laptop as a oscilloscope or something. And then, like, pretty much every experiment I ended up automating. And so I had been doing that the whole while. And in fact, my
Was that so, ethical question, was that cheating? I don't know, I don't actually know, like, or is that just, like,
no, I
galaxy
don't
brain?
like to think that.
That's great. I like it.
Yeah, no, it was amazing. Yeah, so my physics teacher and lab professor loved that, and I ended up actually making this kit for training high school teachers in India on
Oh.
kinematics and mechanics, right? So we made this thing, like, actually used a solder sucker as projectile launcher. Yeah, this is true. The
Yeah,
solder
that's
sucker,
great,
we
yeah.
just remove the tip so it goes faster.
Uh-huh.
We had like just simple beam splitter kind of timing
Uh,
systems. You study projectile motion, so you point the solar sucker at different angles, and you see how much time it takes for the steel ball bearing to drop. And, like, it was just about enough resolution with the old Arduino Uno that you could
mhm.
actually make out the differences from air resistance, which was very exciting for me.
Yeah, right. That's always the catch they get
Yeah,
you with the early physics
yeah.
stuff, right?
But you could actually see
Yeah,
that.
gravity is not 11 meters per second squared, it's a little bit
It's
less.
actually 9.8, but
Yeah. Yeah, right, right. Yeah, that's cool. Wow, okay. And, so, how far and wide did that spread?
I'm not sure. We wrote a paper about it, so there might have been some people who replicated it, but there's this one particular institute which trains for teachers in Karnataka, so they used it pretty heavily. But
That's great.
after that, I kind of actually ended up through multiple things as the engineering consultant for the ecology department. So
Ah.
as like an undergrad student, I at one point had like a room, like a small office, and professors would come up to me and talk to me about their projects, and I would point them to, like, open source hardware resources, or like if
Oh,
nothing existed,
nice.
then we'd make something. Like, so I ended up making all sorts of things, like underwater gates to study like fish decision making,
Mhm.
a bunch of drones for aerial photography.
Did you figure out that fish are pretty not smart?
I think, no, actually, pretty much every time we
Yeah.
have. So I was in an ecology lab, right? And pretty much
Yeah.
every time we've looked at any animal, we found that they're smarter than we thought they were.
Oh,
Yeah,
interesting. Okay.
yeah,
That's reassuring.
yeah,
Less so if you eat fish, I suppose, but
yeah, exactly. Yeah,
yeah.
but
Huh. Cool. Well, that sounds like a good gig though
yeah,
for,
it
like,
was great.
having a range of problems, people come to
Yeah,
you. Yeah.
I
Yeah.
made a
No,
wind
I mean,
tunnel. I made like tachometers to study insect wing beat frequency. My thesis
mhm.
project was this 13-foot tall PCB that measured elephant height in the wild.
Wait, a
Yeah, I mean,
PCB?
it was like
That was the
composed of
PCB?
four separate circuit boards. Yeah,
Still,
it's
that's
yeah,
huge.
yeah,
Yeah.
yeah.
Yeah. Wow.
Took me about a dozen
And
movies to solder that. methane.
Yeah,
But it was
that's
like
good.
a
You put
very
it on and it
simple circuit. It was essentially beam splitter, you know.
uh-huh.
No, I'm sorry, not beam splitter. Like
Beamforming?
not beamforming. Like essentially just had like IR remote LEDs on one side and IR detectors on the other
Oh,
side.
okay. I
And
see. Oh, I see the photo of it on your
yeah,
LinkedIn. It's, like, in the shape of an elephant as
yeah. So
well.
like if an elephant passes through, then yeah,
Uh-huh.
that's what you just cast
Got it.
cast a shadow of whatever's moving through in
Uh-huh.
between. So it's kind of like a line
Ah, that's
scanner.
cool.
Yeah,
Yeah, okay, alright, yeah, that makes sense.
yeah.
Huh, that's super cool. And it's, like, out in the field then too?
Well, yeah, see, that's what kind of happens with a lot of these projects is like by the time we got to a point where we could actually deploy it, I was, heading out of college and, we didn't
Yeah.
have like a lot
Yeah,
of,
just, like, the project
yeah,
timelines and
yeah.
stuff. Yeah. Tell me about India. I'm not sure I think we've had maybe 1 or 2 guests from India, but, like, what's the electronic scene like there?
Oh man, okay, I gotta tell you about this one thing. So back in college, right, I was in Bangalore, which is like a big city in India. And for example, there aren't like things like Micro Center, like even Home Depot for that matter. So the DIY scene is like very spread out, but there
Uh-huh.
is like in
Okay.
every city that one area where you can go to find components. And
Okay.
it's like a bunch of very small shops with very densely packed stuff, but you can find this one store
Uh-huh.
that sells you, like, for example, ball bearings. Okay, and you can just go up to them and be like, hey, I want like this kind of ball bearing, but not in this material but in that material, and they'll work with you to figure it out,
Mm,
right? But you
yeah,
don't get to
yeah.
call them up, really. You have to go over, but
Oh,
it's
really?
great.
But there's one in every big city kind of thing?
Pretty much, yeah, yeah. So
Okay,
in
alright. So,
Bangalore,
you have, like, you have a guy.
yeah,
You got a ball bearing
yeah.
guy, right?
Yeah, so like in Bangalore it was SP Road, and like once a week
Uh-huh.
probably, at one point I would like go there and talk about my projects to the shopkeepers that I'd gotten to know, and like they'd recommend stuff to me,
Yeah.
and I learned a lot of stuff that way, honestly.
Yeah, that's awesome. Yeah, you get, like, that kinda, like, the knowledge just from all the stuff that they've seen. They're like, "Well, you could do it that way, but I've always seen it done this other
Exactly,
way."
yeah, like all the engineering students who go there and like also talk to the shopkeeper
Yeah,
about their projects, you get to learn
yeah,
that knowledge kind of.
yeah. Yeah, it's true, and I mean, like, the convenience of, like, the online stores is incredibly high and much less centralized,
Yeah.
right? But the downside is you don't get that human
Yeah. To
connection,
be
and
honest, I don't know. I think things have probably changed a lot by this time.
yeah. Mhm,
I was in college in 2013, so it's like 10 years back.
mhm.
Yeah.
Yeah, yeah. Yeah, I mean, yeah, exactly, and I think a lot of the distributors that we use here in the States now, I'm sure ship
Yeah,
overseas too.
yeah. Yeah,
It's
they
just
do.
like it's all opened up a lot more, so that's
I think yeah,
makes
but
sense.
like for example, 10 years back, I don't think Adafruit was that big either, right? So like
Mm.
I'm sure they were like
Not as big as they are now, but yeah, they were
they were around, yeah, for
growing.
sure. But
Yeah, yeah.
like the amount of stuff and the amount of
That's
tutorials
great.
and things was much less.
What about industry that's there? So actually, I had when I worked at ABB, we had a factory that was like CM that was in Bangalore. I never had to
Mhm.
go, but like CMs and similar like electronics manufacturing. Is there a lot of local stuff
Yeah,
or?
I'm not too familiar with that, to be honest with you, because I didn't really work very
Mm,
much
yeah.
as an electronics engineer in India, just for a couple of
Mhm.
years after college.
Also, it's a big place, so like I'm sure that there could be, and you just don't expose you're not exposed to it, sort
Oh
of thing,
no,
right?
definitely there are, and especially now there are more popping up. Like I've been hearing about
Hmm.
people using like manufacturing in India, and in fact, like
Hmm.
for the last 5 years or so, there's been this big move of like make in India.
Actually, yeah, Matt Venn, who was just on the show too, he was talking about the Risk Five is really getting big in India as well. And I saw a thing about like India. I think the Indian government pushing for more like semi manufacturing stuff like that.
Yeah,
Yeah.
but I think that one thing that's like importantly that an important distinction I think is even like from undergrad I don't think that people I think hardware is kind of almost discouraged because there isn't as much money in it
Oh, interesting.
for students
Uh huh.
in IITs, for example. The top rankers
Uh
all
huh.
go to CS and not many people
Yeah.
go to
Right.
EE. Yeah,
Hmm.
and
Well, maybe it'll change, over time, because CS is
it's
boring,
so boring.
and See, we know we're on the right
Yeah,
show at this point. We're both like, yeah, CS is boring. We want to talk about electronics. If you were nodding your head as you're listening to this audience, you're in the right place.
yeah.
But we all got our code at some point, so I'm sure we'll get back to that stuff too. Yeah. Okay. Cool. So you're in the States now. What brought you stateside?
So I had worked in India for a couple of years. 6 months of that was actually in California. I was part
Mm.
of this gaming startup. We were making like these vests that you could wear and play laser tag and similar games like anywhere. Like
Oh.
so mesh
Hmm.
communication stuff. That was when Laura was
Cool.
just getting started as well. So a
Hmm.
lot of like, playing around with that stuff. And
Was that fast enough for like gameplay, like
yeah, no,
peer
that
to
was
peer?
definitely one of the issues. I think that we were trying to do 5200 bits per second was the
Uh,
total bandwidth across like, multiple suits, which,
yeah.
if you're trying to do simple gameplay, it's 1 or 2 packets a second is all really what you really need. So
Hmm.
we're just about able to make it work, but it wasn't seamless.
Yeah, I remember when JP was on the show a couple years ago. At this point, he was doing like an alternative to like sub gig alternative to Laura,
Hmm.
but he had worked in Laura, and one of the things that he brought up that I had never thought about before was just like the scaling problem. And there you'd only have so many things talking in a channel. You do have more channels, you have more than one channel, but they're slow. And as you have more devices in a network, you start to have more collisions and stuff like that too.
Yeah.
And so and you think about network capacity in addition to the slow, low and slow chirp that a LoRa is, and I can imagine that would be a lot to work
Yeah.
with.
I mean, I was kind of doing more of the prototyping with XBs and trying to like
Oh yeah,
assume
okay.
that we'll get the LoRa thing going at some point.
Hmm.
But
Yeah, yeah. I mean, XPs are still out there too. They're really expensive, but like they are rock solid. You
yeah,
know, they're really fun to
yeah,
prototype
if
with.
you can get them to work and like especially like the GUI stuff is like so neat. You can just set them up
Hmm.
and like
Hmm.
then they just work. It's pretty good.
Yeah. Yep. Yep. Yeah. That's another thing that I feel like it is good for prototyping. It doesn't scale as well, and for one reason, like just being
Yeah,
costs, but especially for like one of my friends was doing like just a point to point. And it's just like, yeah, it's just like you put two XPs in between, and it's like a serial terminal. It just pops out the other
yeah,
side. It's pretty
yeah.
cool.
I mean,
So that's
but
cool.
also I think that now with a bunch of open source tools and like the what's the I'm gonna butcher this that NR not the
NRF.
NRF but the
Okay.
uh,
Darn, I almost had
yeah,
it.
uh, like one of those modules. Oh geez,
Uh-huh.
it was really popular. Never mind. Okay.
Well, there's like the NRF 24 that's like those are like the really cheap ones that like James Bruton
Oh yeah,
uses.
yeah, yeah.
I
No,
know.
you're right. Yeah, you're right.
Yeah.
Yeah, they were
Yeah.
NRF. Yeah,
But yeah, those are NRF 24s, but then also then all the Bluetooth
yeah,
stuff, and you got ANT and Thread and all the and like Bluetooth mesh now
yeah.
too, which
Does it work?
yeah,
The Bluetooth mesh stuff? I've never played around with it.
it does. I've heard it does.
Oh,
Yeah, I know some people that have deployed systems with it,
that's-
but I think it's in specific scenarios that it's better.
hmm.
A lot of people end up still going like custom protocol. I feel like they use the modems on board basically, in either sub gig or 2.4, and then like you can get it. It's just like a lot more overhead. Then you
Ex-
have to manage a lot more of like the network stack, and it's outside of my pay grade.
yeah, I mean,
For
for
now, I'd
extreme
love to
battery
learn it though.
saving though, it's good to go outside
Yeah,
and like have a
yeah, I
custom
think that's right.
protocol.
So, gaming startup
Yeah. So then I
didn't
moved
go.
back to India and I
Okay.
was kind of starting slash managing the hardware department for this logistics company. They were like a software company, but they wanted to
Oh,
have like a hardware player, right? So
yeah, yeah, yeah,
so it was me and like, a couple of other guys, and we were just like kind of throwing whatever at the wall to see what would stick in like, the logistics hardware
yeah,
space, right? So
yeah. It's like asset tracking and stuff like
yeah,
that.
yeah, bunch of asset tracking, GPS kind of stuff.
Hmm.
In India, a lot of delivery people use
Hmm.
two wheelers. So trying to do
Oh yeah. Okay.
navigational aids for them, like battery charging solutions for them.
Oh yeah.
But what really kind of caught on was I made this handheld laser box size scanner. It's like a very simple laser distance meter essentially, but you
Uh,
could find the size of a box and then, generate
Oh.
a quote for the customer at the point
Uh-huh.
of pickup, which, the way it's typically done is that you measure that with a ruler and
Yep.
then, write it down, and then someone transcribes it at the warehouse. And also at the
Uh,
warehouse, like a laser scanner, an actual conveyor belt laser scanner, does the scanning. But then, of course, there's going to be like discrepancy between the actual size and what the ruler measured, right?
right, and they paid for it a day ago or whatever, whenever
Exactly.
the
So there's like,
yeah, the drop off
especially
was.
with e-commerce giants, right? You can imagine that
Mhm.
the actual difference in these little things ends up being like millions of dollars
Oh, yeah,
all put
right,
together.
right.
So yeah, so that was something that we worked on, like, we got a patent and stuff. And
Cool.
but I don't know, I just felt like the hardware scene in India was too constrained. It was just too small, and I'd kind of peaked where I didn't
Mm,
find many opportunities beyond that. And also I was like, not really too interested in the actual hardcore engineering of it, and I was more interested in creative applications. So,
yeah.
I found this master's program at NYU called ITP, and the best way to
Mhm.
describe it is that it's an art school for engineers and an
Yep.
school for artists.
Yeah.
So,
You are our second guest from
oh
ITP.
really?
The other one is Matt Richardson. Yeah, from Raspberry
Oh
Pi,
no,
now at Raspberry Pi. And, yeah, Matt went to ITP as well. That's I think when I met him, he was at ITP.
nice.
Awesome. Awesome
Yeah,
program. Like, I got to walk through the workshops and just, like, weird, awesome things happening there.
yeah,
Like,
that was a good 2 years for me for sure.
yeah.
Just let loose, and just let your creative process flow.
Is it uncomfortable? So, like, sounds like engineering background, but then, like, is it uncomfortable with the creative aspect, or were you already kinda there?
Definitely, I did feel like sort of it was like reverse imposter syndrome, I guess. But like
Yeah, yeah,
being this guy who's really not that artistic amongst artists.
yeah.
But it was great, at least from a that I could work with other artists and, like, help
Right.
people with their problems. And, like, that's kind of where also I found that, oh, I really enjoy consulting on cool projects, like,
Mhm.
because then I don't own the project, and someone else can take it forward, but I get to do the cool part of actually making, one-offs for artists, which is great.
Yeah. So then in that space, I'm just doing callback like crazy here. So Todd Bailey, who was on the show, also in New York, he did that for a long time, and Mike Harrison as well. Both of them were like kind of like doing engineering work for artists. It does seem like that's like short timeline, tight budget type of work though.
It's
Sometimes, like if it's not well funded
Oh,
well
for
enough.
sure, it's just fun though.
Okay, all right. So once you take the money out of the equation,
Yeah,
you're in a
yeah,
good space.
exactly.
Yeah.
As a student,
Yeah.
you
Okay.
don't think about the money as much.
That's true. That's true. Yeah, I got made it to ramen. I made it to ramen
Yes.
this week, so I'm good. Yeah, I mean, and obviously in New York, it's not a cheap city either,
That's
so
true. Yeah.
that's
You did have
added
to make
toughness.
compromises
But
there for sure. Yeah.
yeah, yeah. So and then did that last?
Well, so during college is when I developed programmable air in the soft robotics class
Mm,
at ITP. So for our viewers, our listeners, programmable air
yep.
is this open source kit that I made for controlling pneumatic soft robots. So it's essentially this,
Nice.
you know, 10 by 10 centimeter PCB with a couple air pumps and a few valves and a pressure sensor, so that you can, like, inject high pressure air or suck air out of a tube, and or, like, let air vent to the atmosphere and, like, get pressure feedback while you're doing this. And it's just controlled
Mhm.
by an Arduino Nano, and, a very simple library that controls it all. And, artists and academics love it for soft
Yeah,
robotics. Yeah.
that's awesome. That is, I think that's the context of you and I meeting. You were showing this off at maybe Open Source Hardware
uh,
Summit. Is that possible?
I was at Open Hardware Summit 2018.
Yeah, maybe it was there. Yes.
You were there?
Yeah. I think maybe that's when we met. When did we meet? We met at some point, and I definitely saw Programmable Air, and you had like the
Teardown 2019 at an after party. I
oh,
think it was
okay,
an
that makes
after
sense.
party at, like, some makerspace or something.
Okay, that we just re-aired Zach and Joshua, who I interviewed at that. They came back on the show 5 years later or 4 years later, and talked about their grad school
Yeah,
experience.
I
So
I,
that
I
was,
remember
yeah,
I listened to that podcast.
right. You were at the same party. Maybe you're in the background.
Yes.
You know.
Yeah, yeah. I remember,
Yeah.
I think I
Yeah.
met Zach for the first time in that party as well.
Oh wow. Okay. Wow.
I had met
It's
Josh
like the
before.
nexus
Yeah.
of the amp hour. Yeah. Yeah. And so this thing you were showing this to me, and to expand on the audio picture of what this is, it's not just the pneumatic piece, but then you also had like these kind of flexible. I remember you had like flexible grippers.
Yeah.
There was like white. It was
It
like
was a
a
jamming gripper. So it's essentially like a latex balloon filled with coffee grain.
yeah.
And when you
Uh
pull a
huh.
vacuum, it just all the coffee beans get stuck together, because they're being pressed from
Yeah.
outside atmospheric air. And between coffee grains, it just so happens that there's enough friction to hold a very solid shape. So what you do is you remove the vacuum, then you place this thing over an object, and it conforms itself around the object, and then you pull a vacuum,
Yeah.
so it becomes like this custom shaped solid that's just about the shape of the solid that you're trying to pick up, and then you lift the thing, and then you
Yeah, it's kind of like if you ever seen someone palming a basketball, if they're just doing with the friction of their hand and not the fingertips, you can kind of imagine that same kind of thing. But yeah, you could pick up pretty big stuff with that. I remember.
yeah, yeah, it's, I mean, so grippers are kind of like the one area where soft robotics is still finding like actual use in industry and warehouse and stuff,
Mhm.
because you can imagine, like, for a automated grocery kind of warehouse, right? It has to pick up like a bag of
Mhm.
chips, or eggs,
Yeah.
or
Right. Yeah.
all sorts of weird different shaped objects. And soft robotics is the way to do that. A lot of big
Mm.
companies are just making grippers for all these industrial robot arms, and some of them are using
So,
vacuum jamming grippers, just like the one that I was presenting.
so like these would be end effectors on like a KUKA or similar, or like
Yeah,
a Universal
yeah,
Robotics. Huh. Interesting. Those systems are like so expensive and so big that I just really don't have it. Like the fact that there's subcontractors, like why wouldn't just the robot maker make the end effector? But of course not.
yeah,
Like these are huge, expensive systems, and they can like bear the brunt of the cost. So
yeah. And
it
you
makes sense.
you once you make something, why not sell it to the other robotics company as
Hmm.
well, right?
Yeah,
Yeah.
yeah. You said soft robotics is not fine. You said the grippers, the jammer gripper is one thing of soft robotics that's finding its place. So
Yeah.
is there other stuff that is not finding its place?
Well, so there's a lot of soft robotics research happening, and there's a lot of art kind of use cases. But in industry, I think that that's where soft robotics is mostly finding its place. I think that eventually soft robotics will find its place in a lot of other places, but there are a lot of interesting challenges because, like, for example, soft robots are very difficult to simulate, right? You need, a,
Oh,
yeah,
right,
right,
right.
and they always
Except in Big Hero 6, they did a good job on that
yeah.
one.
Well, to be fair, Baymax, the character, is not technically a soft robot because it has a carbon fiber
Oh,
skeleton.
yeah, the core
Yeah.
thing. Yeah, you're a good point. Good point.
But and also, like, the characteristics of the robot change with time as it, like, wears and tears, because
Mm.
micro cracks develop all over the place, and, like, the system overall
Ah,
changes. So you need like embedded sensors, and you need essentially like active algorithms that are compensating for whatever's happening with the gripper.
like force feedback kind of stuff.
Yeah, yeah, force feedback kind of stuff.
Yeah. Are they doing that with like vision right now, or how do they
Yeah,
normally
yeah.
do that?
Typically, like,
'Cause-
you just solve it with vision, especially in, like, a kind of warehousing kind of thing. You know if it has got something or not. Yeah,
Right. Yeah. Camera says ball
yeah.
dropped, or back another egg dropped. Yeah. Oh, interesting.
Yeah,
Yeah, it is. I have seen some, like, I think some research papers on it, and I've wondered. I think they always talk about like Mars and like space type stuff too, because you can inflate it. It's also pretty portable. But
interesting.
Baymax is my main reference.
Actually, from Baymax, I think that this one thing will happen in not too distant future, is like a backpack electric car.
Back. Oh, you got to explain that. Okay.
Dude, so like you can have an inflatable car, that like a single or two seater kind of thing,
No, I did not know that actually.
Yeah, I mean, I think so. There's this place called Other Lab.
Oh, I know that. Yeah, they're at Berkeley. Yeah.
Oh, all right. So they actually made a prototype of this, like
No way.
a car that like flat packs, because you have the battery which is flat and wheels that are flat, and this is like, bicycle wheels. So we're not talking like, we're talking like smaller than a smart car,
Okay.
ultra compact. But just the fact
Okay.
that you can have something that, you can take backpacking up, to a mountain or something like that, and then like, ride around is amazing. I want to make one.
I mean, and if you can build it at the top of the mountain, you actually don't need an engine anymore. You could just get gravity. Just need good bearings
Yeah.
and a lot of personal liability insurance. So, what is the inflatable car though too?
So
Then,
I mean, the frame essentially can be inflatable.
hmm.
You can make in stuff really rigid with inflatables.
Hmm.
Also, like, you can design in suspension into the inflatable itself.
That's pretty cool.
Yeah.
So then, but the wheels aren't inflatable.
No, the wheels are like essentially
Okay,
bicycle wheels, with hub
got it.
motor, and
Okay,
like the battery pack is the bottom kind of thing. Yeah.
huh? Okay, like skateboard design sort of thing, like a skate.
Yeah.
Yeah. Huh.
But the roll cage around you is the important thing, is
Yeah.
that, you know, essentially, in terms of like like in terms of electrically, it's like an e-bike or something, right? But
Yeah.
it's
Right.
much
Or scooter or
safer
whatever. Yeah.
because you have an actual seat
Yeah.
that you're strapped into, and there's a roll cage around you.
Huh.
And that's the real value of a car.
I'm going to remain skeptical about that. I mean, I'm sure safer is a
Oh,
relative
yeah, for
term.
sure.
I will not be getting in one of these ever in my life. I would love them to work that into like a James Bond plot, though. That would be really
Oh,
great.
yeah, that would be nice.
Yeah, yeah. Even better if he's inflating with his mouth.
Oh my God.
Yeah, that'd be really great. That'd be really
Jesus.
great. Yeah. Uh, okay, so what happened with the project? Is it still being used in like out in the world? The
I
programmable air?
mean, honestly, I've been really bad about like making new batches. I think I've done like 3 batches so far, and they just sell
Mm,
out immediately. Yeah, and in fact, like today, I have to put together a kit for this academic who wants to use it for some microfluidics stuff, and they're like, "Oh, we are like on a tight timeline, and we can't wait, till June when the next batch is supposed to be like shipped. So, can you
hmm
help us out?" And I'm like, "Okay, I guess, I'll just make one." Like, I've sold like, even like before, so I crowdfunded this on Crowd Supply, and
Yep.
before I ever went to Crowd Supply, I had like already sold like a few dozen of these things that I had hand soldered.
You're like, hey, buddy, you want to buy a inflatable programmable air kit on like the street corner in New York or what?
Yeah, no, I had like this Google form, like I had titled it the super secret programmable air.
Uh-huh.
Yeah, because like I presented it at the 2018 Maker Faire in New York City, and that's where the project
Uh-huh.
really kind of took off. People absolutely loved it, and I didn't realize that, it would get such a good response. And that's how I ended up presenting at the Open Hardware Summit as well, which was actually just 3 days after the Maker Faire. So here I am, like,
Uh-huh.
in
Okay.
presenting, right? And I think one of the organizers messages me on Twitter saying that, "Hey, look at your DMs." Like, she ats me on like a public Twitter or something because I was not looking at my DMs. I think some presenter had dropped out last minute or something. They were like, "Can you present this? Like, we've heard good things about your work
Oh
from Maker Faire
wow.
stuff."
Yeah.
I'm like, "Okay, yeah."
Yeah. Last minute Grammy nomination right there. Yeah.
And it was amazing, and I always
Yeah.
have this kind of passion for live demos. And so I had like
Yeah.
live demos made for Open Hardware Summit, and on stage presenting them. It was great.
That's awesome. And that's a good way to like, yeah, drive interest too, especially when you give a good demo, which I've seen and you do. That'll that's a good way to keep people interested in what you're working on and stuff.
The way I see it is like, it's just a challenge and accountability of, like, does the stuff work all the time? because if
Mhm.
it's not working with me, just by myself on my workbench, that doesn't have quite the impact of it not working in a, showcase kind of setting. So if
Mhm.
I
Yeah.
plan for a live demo, I understand where the system breaks a lot better, because every time it breaks, I will go to the actual root cause rather than just be like, oh no, it's fine, probably it won't do that
Mhm.
again or
Mhm.
whatever. Yeah.
Uh-huh. Yeah. What, so you then crowdfunded on Crowd Supply?
And still selling on crowd supply.
Oh, you are? Okay, cool. I was wondering
Yeah.
about that, yeah.
I think so. Now crowd supply has been bought by Mauser or something, so it's actually being sold on Mauser. I don't know, there's
Yep,
something
yep.
happening there, but essentially, yeah, still selling.
They were actually bought in 2019, I looked at, or
Oh
2018
wow,
maybe.
okay.
Yeah, it's been a while. It's been longer than I thought. I just saw
Oh,
Josh from
so
Crowd
maybe
Supply.
then
Yeah.
the logistics of how they do it has changed, because the last time I had
Yeah.
to send it to Mauser rather than sending it to crowd supply.
Ah,
Yeah.
there you go. Yeah. No, that's a pretty cool thing. I that was a good purchase on Mauser's part, I think.
Yeah.
I like the Crowd
Oh
Supply
yeah,
folks, and
it's great.
but then, like, the logistics stuff, it does make sense if you're gonna keep, like, if you're crowdfunding this thing, you probably wanna keep selling it, and so, yeah, it's just kind of a natural piece
Yeah.
then, so that's great. So that's the runs you're doing are kinda like just to keep the supply
Yeah,
up
pretty
at
much.
Mauser.
I'm lazy
Yeah.
about it, to be honest.
Mhm. Well, it's your product. You get to do what you want, and it's open source. So if you can just tell people, you'd be like, "Well, if you want to do it, just do it yourself."
Yeah, I mean, the only thing, like, for example, is so these valves that I'm using, right, are typically used in these Keurig machines and stuff. And
Okay.
I, so the first several runs that I did, I had to buy like secondhand valves from American Science and
Oh.
Surplus and, like, similar stores
Uh-huh.
that, had these were previously used things that had been taken out of machines. And
Mhm.
I had like a bunch of quality assurance issues with that. That I won't, like,
Yeah.
I think 25% of the valves was just not usable.
Ooh.
Yeah, because
Ouch.
I was
Yeah.
already
Yeah.
running them slightly out of spec of the pressure range.
Yeah. Did you find the quality before it? Yeah, you were like doing in-house testing kind of thing?
Yeah, yeah,
So it
yeah.
was just scrap.
I mean,
That
it's
sucks.
just so then I just gotta like remove the valve and like try
It's a
another
it's a
valve
good way to lose margin.
and yeah. So then when I spoke to the supplier, which it was quite difficult, like, just trying to get a hold of them. But when I finally did,
Yeah.
they're like, they won't even talk to me for anything less than 2,000 pieces.
Oh, yeah.
And like
Yeah.
my runs are like significantly smaller than that. They're like, I'm making like
Yeah.
150, 200 pieces of programmable kits at a time.
Yeah.
So I had
Yep.
to buy like stock in bulk. So like that's, I think, the one thing that I want to in the future change about the project, if I ever get around to it, is like try to get valves that you can, individuals can source as well, in case.
Ah, I see.
Yeah.
Right. Yeah, you could sell a simpler version of the kit. You could do like a DIY kit and make it more sourceable.
Yeah. Yeah.
Yeah, that is tough. I mean, especially with mechanical components where like that is I'm sure understanding the nuances of one valve over another, that actually probably matters
Oh
quite
my
a
God.
bit.
Yeah.
Like when I go and search on like motor sites for like DC motors, I'm like, I don't know what like does it turn around? Like that I think that's important, I just don't have any
Yeah.
knowledge. And so then when they present me with like a search matrix, I'm like, the cheapest, I guess. Maybe the second cheapest. Like when I order a bottle of wine, you always do the second cheapest.
Interesting. Yeah. Yeah. Oh my God. And I think that also the thing is, like, with mechanical components, you have typically the spec sheets are a lot shorter. You don't have nearly enough data.
Oh, interesting. Why is that? Just because of the manufacturer?
Yeah, and I guess, like, it's just the way they're expected to be used uh, in the way, in kind of like the discipline that they're made for, right? So these are meant for Keurig machines, where you have this kind of thing that's boiling water, steam, like, steam is building up, and then you're just gonna switch this valve on, and it's gonna let the steam into and through your coffee pot or whatever, right? So that's what the valve is designed for. So in the spec sheet, uh, the data will kind of be depending on that. So for example, like a big one is the valve is never experiencing pressure in the opposite direction, right?
Aha. Because they had designed other pieces into the system that
Exactly.
don't allow backflow or whatever.
right? So
Yeah,
it's,
makes
so that
sense.
is something that I have to find out myself. So like, and I actually ended up buying like dozens of valves to try to find out something that would work for the kit. And I think that was the main work in the
Yeah,
project, was trying to find stuff that, oh my god, trying to find stuff with the same orifice size so that I could use the same tubes to connect things. That was
right.
such a
Yep,
big
yep.
problem. Was like, you'd find the perfect valve, except that
Right. You order it and then doesn't fit when he gets home, gets to your house.
like it's just like, yeah, the tubing sizes are like incompatible, and then you don't want like five different connectors in your kit, right? So yeah.
Yeah. Hmm. I mean, that is the when you think about like a kit and like one I think you've been. It's not like if I could connect the arc of your career, it sounds like you've been kind of helping that interface for people that are not in the electronic space. You basically build like an API for hardware, basically. In this case,
Yeah.
programmable air, and before like the scientific equipment and stuff like that. But like, that is a huge value, and that's what I look at, like some of the scientific equipment that's out there and just the
Oh
margins
my
they
god.
get, and it's like
Yeah.
it's not the most complex
Yeah.
gear, but it's the tested for the scenario
Yes.
that they need, and that is worth paying for.
Yeah. But I don't think that I should. I do hope, for more open source hardware, scientific equipment stuff, because man, like
Sure, sure.
it's really holding back science is the thing, right?
Oh, sure. Yeah, I'm not
Yeah.
saying I agree with the actual output. I'm just saying that like if there is value to be had in those very high prices that they
That's
charge,
the reason.
it is it is definitely like low volume, but then also, it is proven for the scenario. And like when people can get their scientific electronic equipment onto a paper as well, it's like that's like another proof point basically in showing that like it has done this experiment and you should also do it. So like there's a lot of weirdness in that space, but also I get some of
Yeah.
it. It's kind of the institutional
Yeah.
stuff. Well, I just found the link on Mauser for programmable air, so I will have a link in the so people can check it out. What do you tell people to build the first time? Like, what are people building with it generally?
The kit actually ships with the stuff that you need for making a jamming gripper, except for the coffee.
Oh, come on, man! To source my own coffee. Where am I going to get that? Just like an entire cabinet in my house. Cool. Yeah,
I
that's
think that
great.
that's a good
And
good
that's
way to get started, or just like blow a balloon. That's fun.
mm-hmm.
Trying to,
Yeah.
I think quite a few people have done like balloon as data interface, essentially. Just kind of,
Oh, that's kind of cool. Yeah.
you just the size of the balloon represents whatever data. I think that's cute.
Mm-hmm.
It's nice. Yeah.
That's fun. Cool. That's great. Okay, well, let's move on to the thing that I talked about at the top of the show, which was the
Yeah.
refrigeration stuff. Now, it looks like you were wearing a proton pack at SuperCon. So I saw you
Yeah.
at SuperCon
Yes.
2022. Yeah, that was last
Yes.
November. And yeah, it looked like you were wearing a proton pack. Tell me
Sure.
what it was.
So it's a backpack refrigerator with like a battery powered refrigerator that's dedicated to cooling a single bottle of liquor, right? So the way it works is it's all the components of a regular refrigerator. So it's a vapor compression based system. There's a compressor, evaporator, condenser. The only key is that the evaporator, which is the part that gets cold, is this heat plate exchanger. So you can have refrigerant running through one set of plates, and right next to it is another set of plates that you can run a liquid through. And so, your liquid
Uh-huh.
gets cooled. So I'm taking,
Right. And you're not drinking
no,
Freon. That's another
well,
important thing,
it
right?
also was using propane as a refrigerant,
Propane. Oh, nice.
just for that
Yeah.
extra
Well, yeah.
spice.
Also not something I try to drink on a regular basis, but yeah.
Yeah, so it's very interesting. So it's pulling the liquor from, so the liquor bottle is connected with an umbilical essentially to the evaporator of this backpack.
hmm
And so it's constantly cycling the alcohol, pulling it up from the bottom of the bottle, and then, running it through the evaporator, getting it cold, and then pumping it back out. And the reason actually that it ended up being an alcohol based system is that it was too cold for, a water based system.
Oh
It would
yeah,
just freeze
right, right. It
immediately.
would have just.
So I needed like
Right.
hard liquor so that it does not because it got too cold.
Sorry for party rocking, man. Just yeah, I had to bring the party here. Yeah.
Yeah.
You didn't have to make it Fireball. I'm
Oh
just
yeah,
saying.
no. I mean, there were there were good reasons for it. I just love the pun
Yeah.
of a chilled fireball, you know. And
Yeah, that's pretty
my
great.
girlfriend
Yeah.
loves
Yeah.
fireball, so what am I gonna
Yeah.
do? You make it
That's
a
great.
vodka thing?
So there is a Hackaday talk you did on
Yeah,
this. So it's called ref, Refrigedero?
refrigerdyro. Yeah,
Refrigedero?
there's a there's a
Refrigediro.
story behind the name.
Mm.
Okay, so there's gonna be like three people who are gonna enjoy this, but they're gonna enjoy it a lot.
You know what? That's what podcasts are all about. Just getting those, you get those three people, you know?
So my favorite book of all time is Harry Potter and the Methods of Rationality by Eliezer Yudkowsky, who is this AI researcher. And in this fan fiction, Harry's aunt marries a professor. So Harry is raised into this scientifically literate and loving household. And then he goes on to
You know, this is so refreshing just because most Harry Potter, when you say Harry Potter and fan fiction, it goes a totally different direction. And the
yeah.
fact that it's going to rationality and
Yeah.
science,
The
yeah,
whole
that's
book is
nice.
like a premiere on like rational thinking and all the
Oh,
psychological
wow.
experiments. Like there's
Wow.
a whole series of chapters based on like like Stanford prison experiments.
Was it widely published or was it like one of those things where it's like just a Word document?
So it's on. There's a really good dramatized audio podcast of this, but actually,
Uh-huh.
my girlfriend got me this limited printing
Nice.
hard copies of it as well. Yeah.
Crowdfunding?
Oh man, absolutely
That's
one of my
great.
most treasured possessions for sure. Yeah.
Wow, that's great. That's really great.
But anyway, in this book, there's this spell called Frigidaire, which is like
Fridge.
for cooling things, and from
Okay.
there I pulled Refrigidaire.
Yeah. Yeah, yeah, yeah. I can make that mental leap now. Well, what was the purpose of the cooling spell, and or rather, how does a scientist square with the world of Harry Potter?
Right. I mean, so it mostly it doesn't go into like how magic and science like kind of works. It leaves a lot of things like hanging, but
Hmm.
there's parts of it, like for example, Harry does these very basic like Mendelian experiments to figure out like magic is decided by just one gene, like whether you're magical or not.
All right, that's great. Okay, so basically, it's a premise to just talk about all
Yeah,
the fun
all the
stuff that the author
rationality
wanted to.
stuff.
Yeah,
Yeah,
rationality. Yeah.
yeah.
Okay, that sounds cool. I think I might give that sounds weird and wonderful. So
It's
yeah,
dope.
I think I might give that a
Yeah.
shot. Yeah. Okay, so we got the name, and
So I wanted to. This was right after I had quit my job. I was looking for like I want to do this experiment, like this kind of project that will have an impact, right? And I was like, like
Mhm.
refrigeration industry, like cost contributes so much to like global warming and stuff, blah blah blah, and like there's very little innovation in the HVAC refrigeration space. Like it's hasn't really changed significantly since the 60s.
Mm.
So I was like, there must be something, that can be done there. So I actually had this problem that my laser cutter needed a water chiller, right?
Okay, yeah.
Everything that I could find was like, 300 onwards dollars, right? 400, $500 for a water chiller. And I could buy an ice maker for $90. So I'm like, why can't I convert this ice maker into a water chiller, right?
Hmm.
So I did
Yeah,
that.
yeah.
And, that was pretty easy. And I was like, oh,
It's like dipping the toe,
yeah,
huh?
exactly.
That's the first
And
thing.
then I found this
Yeah.
friend who happens to live like, just a few blocks, just a couple blocks from my place actually, who has like 15 years of experience in the HVAC world.
Uh-huh.
And I'm
Yep,
like,
that'll do it.
hey, do you want to like, kind of do this thing together? And we're like, oh yeah, sure. So we were
Huh.
looking for something to get the conversation started with people about
Yeah.
refrigeration. And we ended up making this backpack like pretty much over a weekend for a party here in New York.
Can you explain the refrigeration cycle? Because I feel like that's
Sure.
you're right that it's this old technology.
Yeah.
It's very energy hungry.
Right.
And I remember something about cycles. And like what I really remember is like in the diagram, there was always this kind of like sideways hourglass shape. and I never understood what that meant.
Ah.
But that's like the expander or the compressor. I don't know. There's something in there.
Mm.
But I just remember seeing that stuff, and I'm just like, none of this makes sense to me, you know. And then the mechanical engineers came in. They're like, Chris, get out of here. You're never gonna get this.
Let
I'm like,
me
okay, fine.
explain it to you from a very practical perspective. Okay.
Can you do it like Harry Potter? Like, can you make it? No, I'm just kidding. Don't do that.
Yeah.
Okay.
So essentially, the system is divided into two sides. There's the high pressure side and the low pressure side. Okay. The compressor, it sucks in low pressure refrigerant and spits out high pressure refrigerant. And as you know, like when you compress a gas, it heats up, right?
PV equals NRT.
Yes.
That's gonna be in here somewhere, right?
Yeah. Yeah. So the N and R are constant, and you're increasing the pressure, decreasing the volume. But yeah, I don't know if PV is equal to NRT is enough to kind of explain this.
Okay.
And there might be some non-ideal gas behavior happening as well.
Sure.
But
Yeah.
essentially,
That's literally the only thing I knew in this space. So I'm out.
uh, but so you're compressing this gas and it gets hot, right?
Mm-hmm.
So you then send it to this thing called the condenser, which is this big radiator, right? And you're blowing air across, and you cool down this high pressure air. So out from the radiator comes this high pressure, room temperature refrigerant. And then it goes through something called the expander, which probably is the hourglass thing that you're talking about.
Okay. Yeah.
Which can be anything. It can be like a small orifice or like a really long and narrow tube.
Okay.
When this high pressure gas comes out of there, it finds itself in a low pressure environment. So it immediately like evaporates, boils. And that expansion is what does the refrigeration. So if you actually look at the backpack, right, you see this copper tube, a thick copper tube coming, and then there's this coil of thin, narrow copper tubing, and then thick copper tubing again. And one side you can see is like room temperature, and then immediately after the narrow copper tube, you'd see like ice forming, on the copper tube, because as soon as the refrigerant gets out and into this low pressure environment, it chills down and cools anything around it. And it's that is the same as like the air duster thing, or a
like when you're using like compressed air in order to like cool down a circuit board to test
exactly.
Yeah, I see what you mean. Okay, interesting. So maybe can we then like on my fridge, my place I store food, they have all the same pieces, right? These are all the same thing. My air conditioner, my fridge, my
pretty much exactly. It's the same stuff.
I don't know what else has it. My other air conditioner. I live in the South now.
That's pretty much it.
Yeah. Okay.
Yeah. So in your fridge, there is a big radiator on the back of the fridge. The entire back of the fridge probably has like copper tubing running, and the back of the fridge gets really hot because that's where it's rejecting heat. And inside is the evaporator. So copper tubing inside the fridge is where the refrigerator, comes in at room temperature and then expands and then becomes really cold. Yeah.
And then, I mean, the reason it's so energy hungry is because the compressor is just a huge motor, right?
Yes. So the compressor is the thing that's doing the work and getting the energy. And there's many ways, like, so the whole refrigeration thing actually is actually really neat, where you can get more than 100% efficiency. And it's kind of like,
wait, really?
What are you talking about? Right? Exactly. So what I'm saying is that if you put in 100 watts of energy into a refrigerator, you can move 200 watts of energy from inside the refrigerator to outside the refrigerator. So if you're counting efficiency,
is that because of the latent energy that's already in the fridge, like the heat coming off of the stuff, like from entropy, is being captured, or what?
No, not quite. I mean, essentially, like, there's nothing saying, if you think of a refrigerator as an engine in reverse, right? So if let's say you have a 70% efficient engine, right? What that means is that you're putting in 100 watts. It's radiating 30 watts as heat output, and 70 watts is going to mechanical input. So if you run it in reverse, you put in 70 watts of mechanical work. It takes in 30 watts of.
Yeah, that makes sense. Okay.
So then it's 100 watts out.
Right.
So yeah, I don't think that quite explains it, but essentially you can move more.
Yeah, it's really because 'cause you're transporting energy as
Yeah,
well.
you're transporting heat. Yeah, yeah,
Right. Yeah, that's interesting. Yeah, it's not like, above 0 or what's it called? Above parity
yeah,
energy transfer. You're still that 100 watts you're
yeah,
putting in are still it's gone. You don't get that back. There's no, like the useful work is moving chemicals basically, right? But in moving of the
yeah,
chemicals is also
yeah.
moving heat. Hmm,
So you can have like the coefficient of performance is like this kind of efficiency. You can have that be like for like
mhm.
really good well designed systems, like more than 5 or 10 even. So you put in 100 watts and you're moving
Wow.
1,000 watts of. But that's not the reason why I think that you can design better refrigerators. Because that's a whole science in itself
Mm,
of designing refrigerant loops that are high coefficient of performance. The reason I think that it can be
mhm.
done better is from design and designing things from a human kind of perspective. Like chest freezers, right,
Mm,
are wildly more efficient than regular refrigerators because when you open a chest freezer,
yeah.
the cold air just stays inside. It
Yeah,
doesn't spill
yeah, stays at
out,
the bottom,
right?
yep, yep,
Yep, exactly. So I'm like, well, if we can, make refrigeration like refrigerator prototypes 10 times faster, right?
mhm,
And do a bunch of user testing, that's how I think that we can end up with better, more efficient refrigerators because, you just find efficiency in a different part of the
yeah.
thing.
It does seem so having looked at the backpack prototype, it does seem like because you need to have, like, a completely closed system, the prototyping would be tough
Mhm.
because it's all brazed? I don't know what the soldered? Yeah,
It does
yeah.
seem like that, yeah. And it is, but as I said, like, we made the thing in like a couple of days,
Mhm,
and it really doesn't have to, like, especially once you get used to it and you're like, if you're specializing in sort of making refrigerator prototypes,
mhm,
then you can be really fast about it because
okay.
it's just brazing, right? It's
Mhm,
kind of like soldering.
yeah, with a torch.
Um, yeah, yeah.
Yeah, that's interesting. Yeah, I think we talked about this when we were at the event, but you had mentioned Kip Bradford was on Adam Savage's thing as well.
Yeah. Yeah, Kip made this kind of kit, which was actually using the same compressor, I think, that we're using. He made
Mhm,
this kit for prototyping refrigeration systems, and it's like, I think it's a condenser and compressor and maybe an evaporator as well, like all in one compact unit.
mhm.
Which I think it's a great piece of kit. Although I've not actually physically used it because it's quite expensive. It's like
Yeah,
five
right,
grand.
right.
Yeah,
Optimizing for different things, right? And that
yeah,
I think
exactly.
Adam Savage has some budget to spare, so that's good. And he was putting on a costume, one of his like walk around costumes, I think, right, to
Yeah.
stay
Yeah,
cool.
so that's great, right? You can have a backpack refrigerator that's cooling your body. That's
Yeah,
amazing. Like, that's the kind of prototyping which I think should happen
yeah,
more.
right. Well, that's don't they need those in like spacesuits too, don't they? Like
Yeah.
to cool them off when they're in the sunny side of the hitting by the sun.
Actually, interestingly, I think in the original NASA spacesuits, they were not using a refrigeration system.
Oh, really?
They were just using compressed refrigerant, which they were just like venting into space essentially.
Hope you don't run out. You'll burst into flames.
So no, you were letting out the refrigerant. You were just exposing it to the low pressure environment of vacuum,
Oh, wow.
and that cooled down the can that it's coming out of, and
Mhm.
you're
Then they had
it,
like a circulator to
yeah, yeah,
huh, interesting.
yeah. So you don't need a compressor at that point. You just come in with compressed refrigerant in your suit.
Right, but that's not a closed system, so you literally run out.
Yeah,
Not to
exactly.
mention
Yeah.
in space, when you let things out a little bit at a time, it's, propellant as well.
Yes.
Better
Well, I mean,
make
you
sure you don't have a clogged
can do
nozzle
that.
there.
You can just, yeah, have a nozzle that's
Yeah,
spreading it out on
yeah,
two directions, so
yeah,
then you
yeah.
don't get a net force. But yeah.
Yeah, but still, yeah, don't have a clogged nozzle, that'd be bad times.
Yeah,
Yeah, have a
that's
good
true.
tether, I suppose, the other thing there, huh? Wow,
Yeah.
that's crazy. So, what do you wanna do with this? I mean, like, I have read things about, like, vaccine storage in different parts of the world is difficult
Yeah,
because of refrigeration. Is that like a intended target or just kinda more seeing where it goes?
that is something that we will eventually get to for sure.
Uh-huh.
There's some very interesting stuff with like ammonia refrigeration, where you can like charge your refrigerator on like a campfire, and
Oh,
then it runs for the whole day
wow.
and stuff like that. Yeah, but right now, actually this backpack might end up in a liquor company commercial or something like that. I'm not
Yeah, I'm sure I could see that happening for sure. I mean,
yeah.
that's the that's the smart money bet, I'm sure. But
I mean, it's just fun, right?
oh, totally. Yeah, no,
Yeah,
this is the joy of building. Like the fact that it made a
yeah.
booze gun at the end is inconsequential. The fact that you know, like when I saw you showing this thing off, people weren't oohing and eyeing at the bottle of booze. They were oohing and eyeing at the back of this thing with a bunch of copper pipes that were
True.
brazed together. You know, like
It was a very specific audience, though, Chris.
it's the best. It is the best audience. That is
That is true. Yeah. Oh man,
people
I
gotta
cannot
go to
wait for
SuperCon.
SuperCon next
Oh
year.
yeah,
It is the best.
yeah.
Yeah.
I'm a bit worried. I'm a
It's
bit
like a
worried. I'm not.
really well kept.
Yeah.
It's a really poorly well kept
Uh-huh.
secret
Yep. Yep.
because it's a small conference,
It is.
but
Yeah.
the people are just so high class. Like all the
Yeah.
best people.
Yep. Yeah. It's one of my favorites for sure.
Yeah.
Okay, so one of the things I wonder about, like, so what are the other hard things about? So one is cost, you mentioned, another is energy input that we talked about. But like, what are the goals? So like in the vaccine storage scenario,
Yeah.
what are they trying to do? Like if that is a target for you,
Right. So I've looked into it a bit, but I have not worked extensively in this. So I take this with a
you got to get that Bill and Melinda Gates money, you know?
So with the vaccine storage stuff, right? The thing is about making a way to transport. So essentially, in the developing world, you don't have good cold supply chain,
hmm
right?
Yeah.
So typically over here, you have these trucks that are refrigerated trucks,
hmm
and shipping containers that are refrigerated as well. But because sometimes you might only have intermittent electricity, so you might end up like, for example, you land, right, and the vaccine is in this container with a bunch of ice, right, and you have to refresh the ice, but wherever you've landed, or like that you're going through, doesn't have ice because there hasn't been electricity for 2 days.
Right. Yep. Yep.
So right, that's the kind of thing that you have to then solve for, right?
Right.
And there was this great project, which was this ammonia refrigeration system that I was talking about,
hmm
where essentially you have this water ammonia mixture. It's essentially called absorption refrigeration.
Okay.
So when ammonia gets dissolved in water, essentially that's a endothermic process, and that cools down the system. So you have this ammonia water system and two containers connected by a small tube. You boil off the ammonia so that it goes into the other container, right? So now you have ammonia in one container and water in the next container. And then when you turn this kind of upside down so that ammonia starts trickling down into the water, it starts, slowly getting absorbed. And that,
Uh,
I think, is what cools down the system. And that, if designed well, with good insulation, can run for a whole day or like even several
yeah.
days
Yeah.
of keeping the vaccines cold. And then when you need to charge it, you can just keep it on top of a campfire,
Yeah.
so that the ammonia then evaporates again.
Yep.
And within an hour or so, it's again separated, and then you can
Yeah.
take it out and
That is an
do that again.
interesting. I mean, especially because you think about like the energy input in that is like pretty,
The campfire, that's
yeah,
the key.
pretty hectic, but also like very accessible, right? That's yeah.
Yeah.
Because like driving a compressor is not just a heavy load; it's also like a heavily inductive load. So like even driving that from a solar cell, I'd imagine would be difficult.
Yeah, essentially there are like RV refrigerators that run the same way as well. You
hmm
can input either like 12-volt DC
hmm
or propane,
Yeah.
and there's a heater like built in, which just burns propane
Okay. Yep.
and runs the same way,
Yeah.
or like or a similar way. That's actually, the cycle is completely different. This is not really a cycle based system. It's like you physically have to turn the device and
hmm
stuff, but
Yeah.
yeah.
Huh. That is, yeah. I'd seen other things about some refrigeration systems also are going to like really high voltage buses, and then they'll do three
Hmm.
phase transforms. So what do they do? What is that called? I remember I had a motor kit that was like, "Don't touch this rail. It's 300 volts. It's 300 volts DC,"
Wow,
and
interesting.
and then it was doing like I think it was a TI kit, and it was doing like motor driving off that really high DC rail because
Hmm.
that was a more efficient way to do it rather than doing like
Interesting.
other AC generation. I really didn't understand how it worked then as well, obviously. But I have seen fridge makers talk about that too, like having high voltage rails inside of fridges as well. Because even
Oh,
if you got like offline power, you have 120 coming in, you generate a high voltage rail and then you do that, it was still more efficient or something.
yeah. No,
I'm
I
talking
have
on
no
my
clue
butt, I
about
think,
that.
at this point. Yeah. So I don't know. It's definitely an interesting space. I mean, like, is there a lot of so like it seems like form factor and application spaces are there's ripe for innovation.
Yeah, for example, there's this company called Gradient that's making these window ACs
Hmm.
that hang on the window, if you can imagine. So
Hmm.
typical window ACs like go on top of the windowsill, right?
Yeah. Yep.
This is the actual system itself is hanging on either side of the windowsill, and
Oh.
you get a flat
Uh
platform,
huh.
so you can essentially use your window, and you get a table,
Huh. That's pretty cool.
right? So that's
So like it passes like the refrigerant line over top of the sill, basically. Like, yeah,
yes.
that's a cool idea.
So you just need the tube going
Uh huh.
to and fro. And actually, split AC systems are way more efficient
Yeah.
than
Right.
the window AC systems. So you get the gain in efficiency as well as, this aesthetic and
Hmm.
utilitarian kind of thing. But so this is the sort of system which, for example, I would say is like, I don't think that you necessarily need to make this like, you need to design it to the nth in terms of efficiency.
Hmm.
Just the fact that it is like, a split AC system, it's already more
Yeah.
efficient.
Right. Right. Right.
So if
An
someone
early
else
design
could,
choice that actually just ripples through the whole
yeah,
system, right?
yeah.
Huh.
But I mean, I don't think that they're actually shipping. They're actually based out of, or at least they have a team based out of New York as well.
Uh-huh.
But I don't know if they're actually they've gotten to ship any significant number of units.
It's not cheap. Just $2,000 for people who are curious. It is beautiful though. I mean, definitely. Yeah, it says early access still on their site. So
Yeah.
yeah, it is. I mean,
Um,
it's really really nicely designed. Yeah, that's a great idea.
yeah, but I don't. Yeah, I don't think that it's necessarily that difficult to make a mediocre version of what they're trying to do,
Hmm.
right?
Yep.
And I think that that's still better than a typical window AC.
Yeah. Yeah.
And the other thing that I think is very interesting is like running air conditioners in reverse as heat pumps.
Hmm. Yep.
So heat pumps are like this, they're in the US, they're kind of said as this new thing that
Finally
like,
catching on. Yeah. Yeah. The
yeah,
Germans are
right.
like, what?
It's been around forever.
Yeah. Right. Right.
But one thing that I kind of am hating is that like when these new window ACs come out with the heat pump feature, right?
Hmm.
The way they'll probably be marketed is like, oh, this is like, super green and stuff.
Oh
And
yeah.
like, you should use it to
Uh-huh.
reduce your electricity bill and like, help the environment. Oh, by the way, throw out your current window AC,
Yeah.
or
Right.
like, give it to us and we'll give
Yeah.
you a $25, $50
Right.
rebate, right?
Right. Right.
And I'm like, but how about let's look at trying to convert your current window AC into a
Yeah.
mediocre heat pump,
Uh-huh.
because a
Yeah.
mediocre heat pump is way better than an electric heater,
Yeah.
right?
Yes.
So maybe there's a small percentage of brands of window ACs with the coils in just the right configuration that you can cut something and add a reversing valve
Yeah. But
and make it into
But
a heat pump.
I don't know.
And
Those are they have squeezed a lot of the money out, a lot of the margin out of those things. They're incredibly cheap for what they are. Like just this, like you
for
said with
window
like
ACs,
yeah, I mean window ACs are
yeah,
super
no, I
cheap.
agree.
Like they're just I
Oh
can't
yeah, for
imagine
sure.
they're not being made to be retrofit, of course. And so yeah, it would
Of
probably be
course
a
not.
very very small group, unfortunately.
I mean, but I don't think that the ice makers were made to be converted to water chillers either.
Oh
But that was actually surprisingly easy
yeah. What
because
was the
there was
mod?
just enough slack in there.
Yeah.
Sorry,
What was the mod you have to do to convert an ice chiller
I,
ice maker to a chiller?
nothing pretty much. I mean, I just removed all the plastic bits
Okay.
and bent some copper,
Hmm.
which was the part that got cold, and dunked it in some water.
Okay.
That was pretty much it.
Okay.
The bending of the copper was the difficult bit,
Yeah.
where I had to make sure it doesn't kink and crack.
Right. Right. Yep.
But there was just enough slack in it that it just worked.
Hmm.
It's not a highly efficient water chiller, but it's cheap. It
Yeah,
works.
right, right, right.
So
Yeah, I think it's just if we're talking to you, that's totally doable. If we're talking to like My parents. I,
Oh
I
no,
actively
so
don't want them to
yeah.
do some of that. Like that's
Oh no,
yeah,
I don't think that anyone who's not like an EPA certified technician should
yeah,
not be
right,
doing
right.
something like that. But I do think that that should be like, because especially there are a lot of grants,
Yeah, yeah,
and I mean, the point is that the actual green thing to do is probably to retrofit.
yeah,
I'm not saying it's gonna make economic sense,
right, yep,
but you can probably make it make economic sense through grants that
yeah,
support it.
right. I see. Yep.
And there can be like, city efforts, and you can maybe have like a kit, right, that of all the tools, and that's,
Mm.
you know you ship it out, or like, a technician comes and
Yeah,
does
but
the
as
thing
a
or
New
whatever
York resident, wouldn't you really miss all of the
stuff
hissing?
that I find in
I
there.
was gonna say the hissing and the squealing and the bumping that New York radiators do as well. I find as a former apartment dweller, not New York and
Yeah.
Chicago, but there's that comfort in that waking up at 2 a.m. with hot sweats because you have to open your window because you're like, what the hell happened here? Yeah.
Yeah, I mean, I think my neighbors in my apartment building woke up at 2 a.m. because I was using the table saw.
Different problem, but very. They got a New York story now. That's great. Amitabh, where can people find your work online?
So I'm on Instagram at tinkermind underscore. That's TINKRMIND without the E.
Yep.
And I'm at tinkermind pretty much everywhere else.
Yep. And you're on YouTube now. You have a new YouTube channel doing that stuff too.
Yeah,
Yeah.
it's at tinkermind as well.
Yeah. That's great. All right. Well, I am very excited to see what you build next. You're always building very interesting things. I hope we see each other outside of conferences, but if not, definitely at SuperCon and other fun conferences.
Sounds great. Always a pleasure to talk to you, Chris.
Yeah. Thanks for joining today.
Thanks. Bye.